Hi, the topic is Huffman coding. Huffman coding is a compression technique. It is used for reducing the size of data or message. Suppose you want to store the data in a file, so you can store the data in compressed form to reduce the size of a file. When the data is sent over a network, data can be compressed and sent to reduce the cost of transmission. In this video, I am going to explain you if a normal message is sent, what will be the cost, and what is the fixed size encoding, then what is variable size encoding, that is Huffman coding. Now let us study the problem. I have a message here. Now this message I want to store it in a file or I want to send it over a network. Then let us understand what will be the cost of a message. So the cost of this message or the size of the message will be measured in terms of bits. Let us check. First of all, there are 20 letters in this one. So the length of this message is 20. Next, how this message has to be sent? It has to be sent by using ASCII code. Electronic devices or computers all use ASCII codes for characters or English alphabet. So these are all characters. ASCII codes are 8 bits. I have used alphabets A to E here, so that is easy to understand for us. So if I say A, its ASCII code is 65 and the binary form is this one. So total 8 bits. These are 8 bits that are representing decimal 65 and that is representing A. Similarly, if I say B, then it is 66. This will be for 66. Likewise, C, D, E. For everyone we have that is 67 and 68 and 69, and here the binary code will be there. So 8 bits are there for each alphabet. Now if normally this message is sent 8 bit for each alphabet, then total number of bits will be how much? As there are 20 alphabets in this message, so this will be 8 into 20, that is 160 bits. Size of the message will be 160 bits. Now this is the simple message sent without encoding. The size will be 160 bits. 8 bit for each alphabet. Now let us look at, can we use our own codes instead of ASCII codes? How it is possible? See, I am not using all English alphabets or all possible symbols on the keyboard. I am not using every symbol from the character set. I am using only 5 alphabets, that too capital letters. Then, do I need 8 codes, 8-bit codes for representing just 5 alphabets? No, few bits are sufficient. So can I use my own codes with less amount of bits? Yes. So next we will see fixed size codes. Here I have taken alphabets in this message, and how many times each alphabet is appearing, I have written the count here, or you can also call it as frequency. A is appearing 3 times, 1, 2, 3. Likewise, you can check all, how many times they are appearing, I have written them here. Total there are 20 alphabets. If you want to see the frequency, then you can say this is 3 by 20, that is 3 by 20, or this is 5 by 20, because total number are 20, so this is 6 by 20, and you can take the ratios. I prefer taking counts, that is easy for working. Even what should be the code? See, I have 5 characters. I don't need 8 bits for just 5 characters. 8-bit ASCII codes are for 128 characters or 128 symbols. But for only 5, let us see. If I have just one bit, then either I can write 0 or 1. So how many symbols I can represent? How many characters? Only 2 characters. If I have 2 bits, then how many I can represent? I can write 0, 0, 0, 1, 1, 0, 1, 1. So I can have 4 different combination, and each combination can represent one symbol. But I have 5, so for that I can take 3 bits. So in this, how many combinations are possible? 0 to 7, that is 8 combinations are possible. So I will take 5 out of that. So let us say in 3 bits I will say A is 000, B is 001, C is 010, D is 011, and E is 100. I have given my own 3-bit codes. I will use this for encoding this message, and this will reduce the size of the message. So it means here instead of writing ASCII code, I will be writing 001 for B and 010 for C. Likewise, go on. When the message is encoded using this one, then what will be the size of the message? As we know well that there are 20 characters and each takes 3 bits. So this will be 60 bits. So size of the message will be 60 bits. And one more important thing we cannot neglect. What is that? When I am sending a message, suppose encoded in this one, now how the receiver will know what are the codes? Even if I store it in a file and then later I want to retrieve, how do I remember what are the codes used? 00 means A only, is it? See, for making it easy, I have taken the alphabets A to E here. The alphabets can be anything. This can be A, this can be M, this can be O, this can be Q. Then how I can know which code is for what? So I should also have the codes, that is this table also along with the message. So this is encoded message and this is the table. Use this table to decode the message. Yes. So message is 60 bit. Then you need the table also, the chart of codes that will help to decode this message. So let us see, you have to send this one also. How much size this will take? See, I have 5 alphabets. This alphabet should be in original form now. Now standard is what? ASCII code. So I must write ASCII code of all these. ASCII code of all these. So for this 8 bits. So total how many? 5. So 5 into 8 bits. This is for what? Characters or symbols. Then for each 3-bit code, for A this is the code, B this is the code, for everything I should also have the code. So total how many? 5. And how many bits for each code? 3. So this is for codes. So this makes how much? This is 40 plus 15. This is 55. And what is the size of this original message? So message is 60 bits, right? And table or a chart of codes is 55 bits. So total how much this will be? 115 bits. Yes. So total size of the message along with the chart is 115 bit. It's not just 60 bits, it is 115 bit. No doubt the size of the message is reduced, but table is also important. So it was 160, now it became 115. So around 35 to 40% of reduction in size from 160 to 115. Right? So this is one method with fixed size codes. Now we'll go to variable size code and let us follow Huffman coding, which will still reduce the size of the message. Huffman encoding. Huffman says that we don't have to take fixed size codes for the alphabets. Some characters or alphabets may be appearing few times, less number of times, and few may be appearing more number of times. So if you give small size code for the more appearing characters, then the size of the entire message will be definitely reduced. So let us see what is his idea. Already we have this table, all the alphabets and how many times they are appearing in a message. So that gives the frequency of those alphabets. Now Huffman code follows optimal merge pattern. Now we have to generate our own code. So what should be the method for the code? So Huffman has given an approach for getting our own variable size codes. So he says that all those alphabets should be arranged in the increasing order of their count. So this is the least one and this is the next one and next one and so on. So they are arranged in the increasing order of their count or frequencies. So the smallest one, then the highest one. So this optimal merge pattern should be followed on this one. So what I should do, merge to smallest one and make one node. So this is 2 plus 3, this is 5. Now next select two smallest and form a node. So 5, 4, 5, 6, these are remaining. Out of this, which are two smaller? Either I can take this 5, 4 or that 5, 4. So I will take this one. So I'll combine this one with this. So this is 9. Now what are the list I have or the nodes I have? 9, 5, 6. These are the two minimum. So combine these two. This is LAN. Then combine these two. Two are remaining now. So this one and this one. So this gives what? 20. So here we got a optimal merge pattern tree. So actually we followed optimal merge pattern, that is greedy approach. Always select two, minimum one, and we got this one. Now this tree will help us define the codes. How? On the left hand side edges, mark them as zeros, and on the right hand side edges, mark them as 1. That's it. Now what are the codes? For each alphabet, follow a path from root onwards. So for A, what is the code? 0, 0, 1. So A is 0, 0, 1. Then B is 1, 0, 1, 0. C, 1, 1, 1, 1. D, 0, 1, 0, 1. And E, 0, 0, 0. 0, 0, 0. That's it. These are the new codes we have. Now you can see some code is of 3 bits and one code is of 2 bits, like that. So even we may have the codes with 1 bit also. Not here, in some examples. So variable size codes are there. Now I can use these codes for encoding my message. Like B is 1, 0. C is how much? 1, 1. C is 1, 1. And A is 0, 0, 1. B is 1, 0. B is 1, 0. And D is 0, 1, 0, 1. Go on. If I use these codes, what will be the size of my message? So for that, how many bits are there for A? 3 bits. And how many times A is appearing? This is 3 into 3. 9. And 2 bits, and this appearing for 5 times. So 5 into 2, 10. 2 bits, 1, 1, appearing for 6 times. So 6 into 2, 12. 2 bits appearing for 4 times. So 4 into 2, 8. And 3 bits appearing for 2 times. So 2 into 3 is 6. So for entire message, I have how many times each character is appearing and their sizes of codes I have taken, and I got this one. Now total number of bits are 45 bits. Size of the message is 45 bits. Means if I encode all, I just need 45 bits. So the message size is 45 bits. Now one more thing we should consider. Along with the message, I should also send this chart or a table or a tree. Then only decoding can be done. Means along with the encoded message, what is the codes, what are the codes used, that should also be there. Then only decoding can be done. So somehow this tree should be preserved or the table should be preserved. Or you can see what will be the size of the table. All these alphabets, I should send their ASCII codes, the standard code. So 8 bit of ASCII code. How many alphabets are there? 5. So this makes how many? 40 bits. Then codes also I should send. So these codes, when they are stored, so how many codes are there? 5 codes, but what are the number of bits? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So this is forming 12 bits. So together, this 40 plus that 12, so 52 bits are required for tree or a table. Tree or table. So what is the total size? Message is 45 bits and a table or a tree is 52 bits. And this will be 97 bits. Yes. Now you can see that it is still reduced from fixed size codes. So that's all about Huffman coding. Now if you want to know the size of the message, that 45, you can know it from the tree also. How? See, this is the distance. How much is the distance? 1, 2, 3. And frequency is what? 2. So 3 into 2. So distance into frequency of each or count of each. You can take sigma, sum of all these. So what this will be? Distance is 3 and frequency is 2, plus distance is 3 and frequency is 3, plus distance is 2 and the frequency is 4. Distance is 2, frequency 5, and distance is 2 and frequency is 6. So this is nothing but this calculation that we got, and this will be 45 bits only. So if you want to know what will be the size of the entire message from the tree also, you can find out by using this formula. If you refer a video on optimal merge pattern, you find that formula is defined. Let us see how decoding is done. This is the message now completely in the binary bits form. Follow the message. For this, you must have a tree for decoding. So start from root, 0 left side, 0 left side, 1 right side. This is B, 0, 0, 0, 1, completed. Then again start from the root, 1 right side, again 1 right side. So we reach the leaf, that is C. So these two are over. Then again, once you have reached the leaf, again start from the root, 1 right side, 1 right side. So this is C. The next 0 left side, 1 right side, it is a D. So these two are completed. In this way, this message can be decoded, and from binary bits we can get back the original ASCII code. So the receiver can convert the message into ASCII code and use it in its machine. So inside the machine, while using, it will not be using the code, so it has to convert into ASCII codes. Like when you have any zip file or compressed file, you have to decompress for using it. Same way, it should be decoded and used. So that's all about Huffman coding.